In this video, we're going to take an I/O table, which are the requirements for a circuit or expression, and take that and convert it to a Boolean expression. And this will be the final piece we need to build design a new circuit. So here is an I/O table. We want to construct the Boolean expression that goes with this I/O table or satisfies this I/O table. So there's a technique to doing this. What we're going to do is we're going to start by looking at the rows that have an output of 1. Right there and there. And let's take a look at this row. Let me... What we want to do is we want to figure out the Boolean expression for each row. So we have our variables P and Q, right? P and Q. What values do they have to be to get this row to be true? Well, P must be 1 and Q must be 0. So if P is true and Q is false, that row will give the correct output, right? Then the output will be true. So if Q is 0, then that means not Q would be 1, and if P is 1, then P is 1, and 1 will give a 1. So this Boolean expression fits that row. Let's look at this next row. Here, both of them are 0. So we're saying this row will be true if P is false and Q is false. Like that. And again, to check this out, we can say, okay, if P is 0 and Q is 0, then this is 0, meaning this whole thing is 1. This is 0, meaning this is a 1, and we have 1 and 1 will be 1. Okay, so what we've done is we've described the scenario, the setup, for the only two ways that our I/O table can be true. So that means if we want our Boolean expression to be true, one of these has to be true. So we can write that as P and not Q. That's that first expression. Or not P and not Q. Like that. And this is, in fact, the Boolean expression associated with that I/O table. And this is called disjunctive normal form. This is written in disjunctive normal form. What that means, it's a disjunction, which if you remember is another word for an or, of conjunctions, which means for and. But this is the standard way an I/O table is evaluated, is into disjunctive normal form, which could then be reduced using techniques that are beyond the scope of this class. Okay. So let's look at another example. Why don't you pause the video and try this one out. Try to come up with a Boolean expression that matches this I/O table, input-output table. Okay, so the first step is to isolate the rows that have a 1 as their output. In this case, we have 3 such rows. 1, 2, 3. And so what we need to do is we need to create a Boolean expression for each row. So here we have if P is true and Q is true and R is true, then we have an output of 1. Here we have if P is true and Q is false and R is true, we have an output of 1. And here we have if P is true and Q is false and R is false, we have an output of true. So putting these all together in disjunctive normal form, we have P and Q and R, or P and not Q and R, or P and not Q and not R. And this is our Boolean expression, again in disjunctive normal form, that fits this truth table. And from previous videos, you know how to construct a circuit from a Boolean expression. So this was the final piece we needed to be able to put it all together, which is what the next and last video does.